In this chapter, we're going to look at lighting in Unreal. Now, the Unreal UDK comes with a really cool lighting system called light mass, which is a radiosity renderer, meaning when light gets emitted by a light source, it actually bounces off of surfaces, scatters around the room, and fills in any of the darks in a really realistic way. It also has other features like ambient occlusion built in. So for an example, we'll take this demo level. I'm going to delete out the lights that I've already created. Notice it went to unlit mode when I deleted my last light. And I'm going to place a new light source just on this wall. Move it away slightly, and then I'm going to shrink the radius way down. You can see in the 2D views, this blue circle is the radius of the light. I'll bring it so it's just barely touching the surface. So in a standard lighting system that doesn't have radiosity, pretty much this is the only lighting you would get, is the surfaces that were touched by this light. But if I save and bake lighting, we'll let that go for a second, you can see that not only was that surface lit up, but the rest of the room got bounce off of that light. And as a matter of fact, that reflected light off of that surface bounced again. And in Unreal, by default, light mass bounces 4 times. So even the darkest shadows on the back side of this wall here is technically still being lit by this light here, just through the properties of the light bouncing around the room. So what that means for you as an artist or as a level designer is that you can really quickly and easily create really good realistic lighting without having to worry about manually creating that bounce effect. So let's start by looking at the properties on this point light, see what you have control over as a designer. As you already saw, if I'm in scale mode, I can make the light larger and smaller. But just like the surface is, I can press F4 to bring up the properties on the light. Now, a lot of these properties are shared, like if I select the player start that I've got in the level over here, you may notice that a lot of the same options are available: advanced, attachment, debug, display. Those are kind of shared by all objects. But generally you'll see something, for instance, for light source, there's a rollout called light. And then all of those lights properties are under there. So let's open point light component. So this is where our radius control is. You can manually type in the radius you want. So let's say 500. And now I've got a bigger light. Or there's a cool part of the widget where if you click somewhere in the middle of it and then drag, you can change the radius in real time. Now you'll notice a lot of widgets in a lot of properties menus have this control, so that's a really good way to really quickly and easily control the properties of your object in the world without having to type in the exact number you want. So let's look at the light component settings. This is kind of where there's different types of lights in Unreal, and this is where all of their shared settings go. For instance, if you've got a spotlight or a directional light, they'll have all of these same properties. So I guess we'll start alphabetically. At the top, we've got a property called brightness. It's got the same sort of control as the radius, so I can click and drag to the right to make the light brighter or darker. So we'll crank this one up a little bit, maybe 5-ish. A lot of these properties are a little bit more advanced. You shouldn't need to worry about them right now. For instance, cast shadows, you probably don't need to care about that. So the next one we'll look at is the light color. And if you click on the little magnifying glass icon, that'll bring up a standard Windows color picker. So usually when I'm playing with a new setting that I haven't tested before, I like to go for really extreme values just so that I know it's working. And then later on I can dial it back to something that actually looks good. So let's go for like a really bright red color and then hit OK. And now it's really obvious that that's working immediately in the world. So let's, now that we know what that does, let's set it to sort of a dull, sort of peachy off-white color, something that's a little bit more natural for a natural light. All right, so actually that's about it for light component. I mean, most of the time brightness, color, radius are the main things you're going to need to control. But if we scroll back down underneath point light component, fall off exponent also gives you some pretty interesting control. If I start modifying that. So this is a different type of widget. Notice it's got the little up and down arrows, and I can click on those to make the number bigger or smaller. But if I put the mouse right over the middle of it, the icon changes to a little up and down arrow. If I click, I can now drag up and down to change the setting. And you can sort of tell in the viewport, as I get to a bigger number, the light seems to fall off faster. It still reaches to the same radius, but it stays really sharp in the middle and then gets dark quickly. Versus if I go for a really low number, like less than 1, it almost becomes a perfect circle. The light still goes to the same radius, but it falls off very slowly. So usually you won't have to tune that. The default value of 2 works pretty well. I think it's 2. Yeah, 2 works well for a lot of lights. But if you need something that has a little bit more punch to it, like if you've got a torch near a wall or something like that, you can crank it up a little bit to get a little bit more control of the effect. So I'd like to quickly go over some of the bake settings, because that'll have a huge impact on the amount of time it takes you to build lighting in your level. If you click on the Build Lighting button, the main thing we'll be concerned with is the build quality. If it's on preview, what that essentially means is it'll build as quickly as possible, but it's going to lose a little bit of fidelity. Shadows won't be as sharp. The bounce may not be as accurate. It may be a little bit more grainy. Versus if you do production, that's going to be the highest quality lighting, but it'll take probably orders of magnitude longer to build. So you can choose any of these settings based on your needs. If you're just now experimenting with the lighting, learning how it works, preview will let you iterate quickly. If you're set dressing, if you're just placing meshes and trying to get the scene to look good, preview might also work well. But if you're working on the lighting and you've got a couple hours to let it bake, for instance, if you look at DM Sanctuary, that may take a couple hours to build. You want to do a production quality there if you're doing the final render. Some of these other settings are really useful too. These first 3 will let you sort of bake only certain sets of objects. Obviously, build BSP, build static meshes. You can turn off either of those. That'll have a big speed up on build time. Or build only selected. Say you've got just a single room that you want to build. You can do a Control-Alt-Drag to select it, and then build only that room. If you're doing a build all, then those light properties are here, this icon. You can right click and then choose which build quality you want to use. So while you've got a simple level like this, I recommend giving it a try. Try a build on preview, try a build on production, and watch the timer and see what the time difference is for baking one versus the other. And it will probably be pretty significant. So next we're going to look at a couple different types of lights and advanced renderer settings. But first we need to make an adjustment to the sky dome. I'm not going to go into too much detail, and we will cover this fully later on. But effectively we need to turn off shadow casting on the sky, because right now it's going to block some of the things that we're going to do. So I'm going to bring up its properties. And this is a great opportunity to show another feature of the properties editor, which is the search tool, which is this box up at the top here. I know I want to turn off shadow casting, so I'm going to search for the word shadow. And this will bring up any property that has the word shadow in it. And then I can easily just turn off cast shadow and cast dynamic shadows. And what that'll do is later on when we create a sun, when we create some environment lighting, that'll allow it to pass through. The sky won't shadow those types of light. There are a bunch of different types of lights we can place in Unreal. Obviously we've looked at a point light already, which you can think of like a light bulb. It emits light uniformly in all different directions. And of course, you know the hotkey for that is hold L and click on the ground. That's probably the most common type of light you'll create, but like I said, there are a couple others too. To get at those, we need to go into the content browser, and there's a tab at the top called Actor Classes. Now, this has lots and lots of different stuff, like we can place weapon pickups from here, we can place path nodes from here, but all the different types of lights also are under this interface. So about halfway down, alphabetically, you should see the word light. If you open that up, there's our point light. It's exactly the same we've been placing so far. But we've also got directional lights, skylights, and spotlights, and then a couple other special case things like UT pickup lights. Just in general, keep in mind anything that's in bold is something you can place in the world. something that's grayed out, you probably don't want to place. So let's start by placing a spotlight, which is pretty much exactly what you would expect. Well, it's like a spotlight in the real world. So to place it, I'm going to select that, and then I'm going to give focus to my viewport. I'm going to click and drag in there, and then I'm going to hold A and click, and that's A for actor. And that'll place a spotlight wherever I clicked. You could also do this from the right-click menu. Right-click, add spotlight here. And note that if you forget to give focus to your viewport first, it'll select alphabetically within the actor browser, so it'll select actor all the way at the top. So if you forget about that, you can always use the right-click menu, but it's a little faster to hold A and click. So I'll get that out of the way. Now I can move and rotate my spotlight wherever I wanted to, and it's pretty easy to use. But there's another feature we can use that makes it even easier, which is this icon here, Lock Selected Actors to Camera. And what that'll do is whatever I've selected, as soon as I move the camera, it'll take that spotlight and make it shine out straight forward from wherever my camera is facing. So I can essentially use it like a flashlight, like I can move it high up on the ceiling, pointing down at this ramp and this ledge here. And then I can turn off Lock Selected Actors, and I can see, oops, I guess I left it embedded slightly in the wall, but effectively I left my spotlight right where the camera was. And so now say I want to move it forward slightly, I can press tilde to go into local mode, and then I can just move it forward along its x-axis. So there we go. Now the other way we can use it, if I have it deselected and I go into lock selected actor mode and then I click on the object, it'll pop my camera so that I don't have to readjust the orientation and the position. So play with that a little bit. It's a little tricky at first, but it can be extremely useful. So let's look at some of the properties of the spotlight. I pressed F4 to open it up. Again, we've got light component, and then we've got some of the other settings from before. We've got point light component, which is where our radius is. Radius is a little counterintuitive with a spotlight, but you can think of it as how far does the light reach. If I drag this so the number gets smaller, the light doesn't reach as far. If I make the number larger, it reaches farther. In effect, a spotlight is it's exactly the same as a point light. It just has a cone built into it. It only shines in one direction. So the same controls for radius and for fall-off exponent, they work exactly the same. It's just rather than the light shining in full 360 degrees, it only shines in a certain angle. So that's point light component. We've got light component, which is where we've got brightness and color, just like before. And then we've got spotlight component, which has the special properties that only a spotlight has. So we've got outer cone angle, which is how big of a cone the light shines in. So I can make it very narrow or very wide. And then inner cone angle, which if it's at 0, that means it's going to have a very soft fall off from the center to the edge. And if the inner cone angle gets large, if it gets close to the outer cone angle, let me just type in the number, 56, we're essentially going to have a very hard-edged spotlight. There's going to be very little fall off, and it's going to be very uniform lighting everywhere within the radius. So some pretty cool features. Ultimately, the radiosity eventually takes place once we bake, and so a lot of this ends up being a little bit fuzzy. So if you're new to the tools, just get it in the right ballpark first, bake, play with the brightness, and you should be able to get pretty much what you're going after. So this is probably a good place to pause and bake lighting. Let me just set this back to something a little more sane. Set the inner cone angle to 0, and let's make it a little bit narrower. Yeah, that looks pretty good. All right, so we'll bake lighting, and all these settings should be good, and we'll leave it on preview quality. All right, so you can see the light actually bounced around quite a bit. It really filled in all those dark areas. Even bled outside quite a bit too, although not as much obviously as inside. Um, this may feel a little too aggressive right now. Like in real life, if I was shining a spotlight here, it doesn't seem like it would fill up the room this much. So we can actually change those settings so that you can control how much the light bounces. And that's under this menu here. Go to View, and then World Properties, and then there's an option for light mass. And this contains basically all of the settings for how the bake happens. So the first one, we'll kind of go through these one at a time during this chapter, but for right now, diffuse boost is the one that's really causing the light to bounce again and again and again from each surface. So let's set that to a much smaller number. Let's set it all the way down to 1, which means we'll get about a fifth as much bounce as we were before. So let's rebake. All right. And so you can see now that spotlight has a much more obvious effect. We are still getting some bounce. It's still making its way into the shadows back here, but it's not nearly as aggressive as it was before. And this feels a lot more, I guess, a lot more like what would happen in the natural world. But the setting is there for you to use, so depending on the scale of your level, depending on what types of assets you have in it, or your lighting scenario, a larger number may make more sense. But let's leave that at 1 for now. Let's leave the interior alone for a little bit and let's go take a look outside. There are 2 things we're going to need to add to make any outside space look really good. First is the sun. So in this case, it's a near sunset scene. So we'll make a sun that's low to the horizon in kind of a warm peach color. And then we're going to need to add an environment light, something that captures all of this blue-gray light coming from the sky in all directions. So for the sun, I'm going to go back to the content browser, go to the actor classes tab, and we can add what's called a directional light. Basically works like the sun does. It's like infinitely far away and all the rays of light are traveling in the same direction. But Unreal has something special. If you hit the little plus icon, it's got something called a dominant directional light. Now this is sort of a special one-off that should only ever place 1 in your level, but essentially what it is a light that has really good high quality shadows. It's got much better specular reflections off the surfaces. It's very well suited for being a sunlight. So let's place one of those in the scene. And I'll use the lock selected actors tool to orient it. And I'm going to set it up. So we saw the horizon. The sun looks like it's over there. So let's make it so we get like nice shadows poking in the doorway here. That looks pretty good. So I'll unlock the camera. Now let's get that out of the way. If I bring up the properties on this light and dig in, you can see it doesn't actually have as many settings as the point light and the spotlight. Really all there is to it is brightness, color, and then kind of all the same cast shadows and all those settings like before. This light doesn't even have positional information. No matter if I move it up and down, if it's behind this wall, all the rays of light are traveling in the same direction, so it doesn't even have any directionality to it. So let's set this up. Let's crank up the brightness a little bit. For the sun, that's a little too bright. For the sun, I usually like, yeah, something about like that. Something so that the brightest parts of the textures are just barely about to be blown out, but not quite. And then let's give it a color. Sort of a nice, sort of peachy cream color. Nothing too saturated. Remember that this light will bounce around and fill in and layer on top of itself. So if you pick a color that's too saturated, it's really easy to get something that looks kind of cartoony or CG. So take it easy initially, and you can always crank up the saturation later. So let's give that a bake and see what it looks like. Cool. That filled in the scene pretty nicely. We've got some pretty nice bounce. So this wall is bouncing and filling in the back of the pillar here, but the shadowed area, it stays pretty dark, and we got a nice soft fall off on the shadow, on the edge of the shadow. So let's add in our environment light. Now because that's more fundamental to the renderer, there's not an environment light you can place in the scene, so that actually lives in the light mask settings. So that's under View, World Properties. There's a rollout called Light Mass Settings, and it's Environment Color and Environment Intensity. So for the color, I'm not going to use the color picker. I'll show you something new, and that's this little mouse pointer icon here, which allows me to actually sample a color from the scene. So I'm going to click on that, and then I'm going to click on the sky somewhere like in the bluish area where there's a little bit of blue sky poking through. And you can see that filled in this color swatch with the color I picked. So let's crank up the blue just a little bit more so that it shows a little bit better in the shadows. Now, like I said, that's kind of fundamental to the renderer. It doesn't actually exist in the scene. It's just something that's calculated when we bake. So can't see it quite yet. So let's bake. Okay. And there we go. Now you can see this whole area outside got much cooler now that the environment light is sort of filling it in. It's especially visible in the shadow on this pillar here where it was almost black before, but now you can see it's getting a lot of blue light from the sky, and really none of the warmer light from the sun is getting to bounce there. So that's looking pretty good. Obviously there's more tuning we could do, but that basically covers the major light types that are used to build pretty much any level. We've got the dominant directional light, which is used for our sun. We've got an environment color, which is used to fill in anything from the sky. And then inside we've got a couple point lights and spotlights, which really would be used with a specific light source, like a lantern or something like that. Now, like I said, there are a couple other settings, like if I bring up my dominant directional light under light mass, if you look at this in a different level, you'll notice that they've tuned some of these settings. All of this has an effect on the bake. You can control how much it bounces and sort of how sharp the fall off is of the shadow, stuff like that. But a lot of those extra features I'm not going to walk through. You're better off looking at the documentation online and either looking at existing levels or just trying it out for yourself. So there are a couple different types of lights we haven't covered yet. If I go back to the actor classes browser, you may have noticed something called a skylight. This kind of isn't really used anymore. It was more important in earlier versions of Unreal that didn't have radiosity rendering. But essentially what it does is it creates an ambient light that passes through everything. So you probably don't need it. It can be a little bit useful in early phases when you're just prototyping your level. And it can be good if you've got some really dark areas that don't have any light getting to them. It can be a good way to fill those in, but it does tend to wash everything out, so I personally avoid it. You've probably also noticed if you hit the little plus icon, there's different subclasses of these lights, like a point light movable or toggleable. If you're doing environment lighting, like we've been doing so far, you shouldn't need to worry about those. These are for if you're doing more scripted events later, like if you've got an elevator that moves up and down that has a light on it, that would be a point light movable, or a light that you can turn on and off would be toggleable. But those tend to be more expensive, so don't use them for environment lighting. One other cool feature of Unreal is that it can use a mesh as the light source. Think of a neon sign would be the perfect example, where the tube itself is what's emitting the light, not any given point floating in front of it. So let's head back inside. I'm going to go to the content browser, filter by static meshes, and then I'm going to search for the keyword light. Now a lot of these light sources have what's called an emissive property. For instance, this one right here, if I open it up, I can rotate around in the viewport. Like the underside isn't lit up, but no matter how I orient it, this part here is glowing. That's because the material was set up with an emissive texture. So we could place this in the world, and any place that's emissive will actually glow and emit light in the scene that will then bounce around. So let's grab this one, this Turk lamp. I'm going to hold S and click to place it in the world. Rotate it around. All right, so by default it won't emit light. That's a setting that we have to turn on. So I'm going to go into the properties. Now this lives under, like I was saying with the lights, every mesh type tends to have its own rollout. So this is a static mesh actor, static mesh component. There's a category called light mass. light mask settings. To turn it on, we need to hit this setting, use emissive for static lighting. And then we can use this option here, emissive boost, to control how brightly this object glows. But let's leave it at the default value of 1 for now. Of course, that's where it lives. You could always use the search tool once you know the keyword emissive, and that'll give you your emissive boost and that flag that we just turned on. So if I bake now, there we go. This light source mesh has now become a real light source in the scene. So that about covers it. Again, we're going to use this level for a lot of testing going forward. So at this point, make sure that all your lighting looks pretty good, nothing too totally out of control, and save your map off. And then let's move on. So what I'd like to do is go over everything that we just looked at and see how it's used in an actual Unreal level. It's one thing to know what all the options do, but it's another to know how it's actually used in practice. So I'm going to go to File, Open, go back up to the Content folder, go into Maps, and load this one, VCTF Sandstorm, and that stands for Vehicle Capture the Flag. So if you haven't seen this map before, take a few minutes and browse around it. It's a pretty big open map because it is a vehicle map. Now, it can be kind of hard to find all of the light actors if you're just searching for them in the 3D view. Fortunately, we don't have to do that. There's a tool you'll see at the very top of the window called the Find Actors tool, and it looks like a pair of binoculars. If you click on that, you can basically type in any keyword and it'll search everything in the level and show you the matches. So we want to find all lights or anything with the word light in it, so let's just type light. And you'll notice it's searching inside of the name and it's anything containing the word light. And this is pretty much everything we've looked at so far. We've got a dominant directional light, which is probably the sun. We got that light mass importance volume that we built, a whole bunch of point lights, a couple spotlights, and then some armor and health pickup lights, which we don't really need to cover. Those are kind of a special case thing for Unreal Tournament 3. Suffice to say, they're just a really small point light that automatically gets generated on top of different types of pickups. So yeah, not much to it. Directional light, point light, spotlight, light mass importance volume, and then of course they'll have some settings set in the world info. So let's go through all those quickly. Let's look at the dominant directional light. I can either click on Go To, and that'll zoom the viewport to it. But like we said, the position of this really isn't that important. So let's just bring up the properties. So I can select it and then hit Properties here. And we're still filtering by emissive, so I'm going to clear that out. Go into light, light component, light component. So their sun has a brightness of 14. So you can tell any setting that's different than the default will be in bold. So you can see brightness is in bold, and for instance cast shadows isn't, so that means that's the default value. So that can be a really good way to analyze what's been done in an existing level, is look for whatever's in bold. So we got a brightness of 14, a light color that is this sort of rosy peach color, which pretty much looks like what's in the scene. And really that's about it. Under light mass, so these settings here kind of affect the way that the light bounces. That's what indirect lighting scale means, I believe. Basically, this is more advanced stuff that I don't have a ton of time to cover on the DVD, but if you go to the UDN webpage, you can read up all the light mass documentation and figure out what all these settings mean. So that's the sun. Let's go to the world properties. View, world properties, light mass settings. Okay, so they've got an environment color set, which is actually pretty saturated blue color, which you can kind of see in the shadows here. It's getting a lot of the bounce from the sun too, but they're definitely a lot cooler shadows than the sunlight. They've cranked up the intensity. There's that diffuse boost. The default was 5. We brought it down to 1, but they've kept it a little bit higher. Ambient occlusion is another feature of the renderer, which essentially, you can sort of see it in the corner here. As it gets deeper into the cracks and crevices, the scene will get a little bit darker. It kind of deepens the shadows. And then there's a couple options for that. So again, you can look into the light mass documentation on the UDN website for more information on that. So let's see what else they've got in the level. We got a couple point lights. If I click on Go To, that'll zoom me to it. So it looks like they've got a mesh that has some lighting on it, and they probably just wanted to crank up the light from that even more. So there's a light there. There's another light fixture inside, so they probably just wanted a little bit more light than the mesh would give off, or they wanted it to be more uniformly in a circle. You'll probably find a lot of that if you click on these point lights is just a light source in the level that they wanted to boost up a little bit more. And let's see, spotlights, yeah, kind of the same thing. There's a light source. They didn't want to use the mesh lighting. They wanted a really sharp circle of light on the floor. So that was how they achieved that. And then of course the radiosity takes care of the rest. So you can kind of analyze any Unreal level using that technique, using the search for actors, or the find actors tool, search for the word light, and see what they placed in the level. So at this point, you've probably gathered lighting comes from primarily two sources, the sun and the sky. So when you're lighting your own map, that's probably the best place to start. Get the sun set up, get the sky set up, tune the values until the bounce and the color and the intensity is exactly what you're going for. And then you can start to fill in sort of these secondary areas like this interior here. And you can tune the brightness and you can tune the color based off of what's going on in the surroundings. You'll save a lot of time and I think get much better results doing it that way. But that said, there's one other thing that has a really major impact on the look, and that's the post-process settings. I'm going to skip back to the DM Sanctuary map, and we can preview post-process by going into game mode. You can hit this icon or hit, whoops, press G. There we go. So if I fly into the interior here, you can see things are a little bit washed out and gray out here. And once I move deep enough inside, it pops and it gets much warmer and kind of gets brightened up a little bit. You can see the threshold is right here. So what they've done is they've set up a post-process volume that pretty much surrounds the entire interior of the sanctuary. So anytime you're in here, it uses one set of post-process settings. Once you move back outside, it uses a different set of post-process settings. So you can control that in two ways. You can control the global settings by going to View, World Properties, World Info, and then there's an option, Default Post-Process. So we'll go into what these mean in a minute. And then you can control the post-process volume. You can kind of create it pretty similar to how we created the light mass importance volume. Take your builder brush, fit it around the shape and the size you want, right-click on the Add Volume button, and then choose Post-Process Volume. So we'll do that in a second. But you can also find the post-process volume that's already in the level by clicking on the Find Actors tool, the little binoculars, and type in Post or Post-Process. And now I can go to the properties on that. And if I open up Post-Process Volume and then Settings, this is all of the same options that you could find underneath the world properties. So personally, I like using a post-process volume the most. I feel like it gives me a little bit better control, and it has the benefit you can easily copy and paste it between levels. So let's actually do that right now. So I've got this one selected. I can go to the Edit menu and then copy, or I could just hit Control-C, the standard Windows shortcut. Now I'm going to go back to my BSP Room 04 map, the one that we've been working in and doing lighting in. And now I can go to either Edit Paste, and what that'll do is it'll place it in exactly the same place it was in the previous level, or I can click on the floor and choose Paste Here, and that'll center it around where I pasted it. So now essentially we've stolen the post-process volume from the sanctuary map, and we've got exactly the same color toning settings that were in there. So let's drag that off to the side. We'll keep it around for reference, but I want to show you how to make your own. I'm going to take my builder brush. Let's do the same thing again as with the light mass importance volume. I'll sort of build it to be the right shape and size. Again, I'm resisting the temptation to just scale it because I want to make sure it stays on the grid. All right, so it's the right size. Right-click on volumes, post-process volume, and if I move my builder brush out of the way, there we go. And now in the viewport, as long as I'm in game view, let's see, where's the big one? There we go. So if I fly into here, you'll notice that its post-process settings take effect. So what that means is we can set up our own custom ones on this level here. So I'm going to go to its properties, F4, just like anything else. Open up post-process volume, settings. Now let's run through from the top to the bottom, and I'll explain what a lot of it does. Maybe not everything. All right. So one last little feature. If you click on this icon here, the little lock icon, then you can click in the viewport to deselect the post-process volume, and then you can keep the properties window open without having to see that box selected. So that can make it a little bit easier to tune. So ambient occlusion is, we talked before about the baked ambient occlusion, which adds detail in the shadows. This is a real-time one. You can see sort of along the crack here between the flat wall and the pillar. If I turn it on, it gets just a little bit darker. So that's something that just sort of helps add depth to the scene. Bloom happens whenever there's a really bright light. It essentially takes that color and bleeds it outward a little bit. So you can see it happening on this light fixture inside of here. So I can change the bloom scale. Of course, whenever I deselect the viewport, it goes away. Well, anyway, you can change that number to change the radius at which it's going to bloom. Oh yeah, duh. The light has a sort of flickering in it, so that's maybe not the best example. But the bloom scale will sort of change the radius. Depth of field, it's something that's off by default, but you can turn it on, and what that does is blurs things that are farther in the distance. So bunch of different settings. I'll let you poke around at what those do, but you can see I was able to blur out the entire sky just with the default settings. Motion blur, let's not get into. Where things really get interesting are down at the bottom. Scene desaturation, scene highlights, midtones, and shadows. Desaturation pretty much does what you'd expect. I can crank it up. The closer I get to 1, the closer to pure grayscale it gets. I don't think you'd ever want to crank it this far, but what you can do is leave it at a very small value, like 0.05 or maybe even 0.1, and it just sort of unifies all the colors in the scene. If you've got lots of different textures, lots of different light sources, some a little bit blue, some a little green, some a little orange, just a little bit of scene desaturation can help pull everything together pretty nicely. And then highlights, midtones, and shadows allow you to change, essentially tint the scene. The highlights, well, that changes the brightest part. You'll notice the settings say XYZ. That pretty much translates to red, green, blue. So if you think X is red, if I make this number smaller, it adds more red to the scene. If I make it bigger, it leaches red out of the scene. Personally, I found the scene highlights easiest to work with if you're going to add a tint to it. So, so Y is green, so I can crank up the green a little bit, crank up the blue a little bit, crank up the desaturation a little bit more. Maybe not that much. And now I've got a totally different feeling scene than I did before. Um, Midtones and shadows get a little bit harder to work with. It's just the way the numbers work. Don't feel quite as straightforward. Um, but you can see here, I'm cranking the green down in the midtones, so I still have the greenish color in the brightest areas, but now it goes opposite of green, so it goes kind of magenta in the midtones. So it gives you more control, but usually you can get most of what you need just by changing the highlights. And then likewise with the shadows, any change you do kind of crushes or washes out the colors, so you got to be really careful with those settings. But play with all those. Like I said, it can be really useful to have a post-process volume. You can fly into and out of it. You can control one area versus another, and you can copy and paste in between levels. So it's a really nice, powerful tool. So we have one more topic to cover with lighting, and that's light maps, which is kind of behind the scenes, how is all of this lighting stored? And it's a really important thing to understand in order to get good results. So I'm going to go inside here, and yeah, I'm going to work just on the wall right here. Let's place a new spotlight. Go to Actor Classes, Spotlight, hold A and click to place it. Oops, I'm still in game mode. I'll use Lock Selected Actors and point it at the wall. And let's crank up the intensity of this light, or the brightness, something like that. I'm going to get rid of some of these other lights too, just so that it's nice and clear once I make what's going on. Maybe move it up. All right, there we go. So let's find something we can use to cast shadows. I'm going to go back to the content browser. Filtering by static meshes, I'm going to search for tile floor. And let's use this one here, the one with all the broken parts. I'll hold S and click to place it in the scene. Move it away from the wall, rotate it around, and let's scale it up a little bit just so we can see the effect of the shadows. Obviously it's not casting dynamic shadows just yet, but let's give it a bake and see what happens. Alright. So what you can see on the wall is kind of a really blobby, blurry version of the silhouette of the object. Now there's a different view mode. We're currently in lit mode. The icon to the right of it is lighting only, so that'll get rid of all the texture detail. And this is what the light map looks like. It's, well, like I said, kind of a blobby, blurry version of the silhouette of the object. So that's something that we actually have control of. If I select the object and go into its surface properties, press F4, on the right-hand side, there's an option for light map resolution. And right now it's a value of 32, which essentially means every 32 units in Unreal space, we're going to have one light map pixel. So you can see essentially this little white cross shape here is one pixel, this cross shape here is another one, and those are spaced 32 units apart. Another tool I don't think I've shown you yet, if you go into a 2D view, you can click and drag with the middle mouse button, and that'll give you sort of a measurement tool. Can be handy in a lot of situations, but you can see right now 32 units is 2 grid spaces. Well, this mesh is only 160 units long, so that's like a good chunk of its length. So it's only going to have maybe 5 or 6 light map pixels. Anyway, what we can do to increase the resolution of this is move the pixels closer together, or pack more of them onto the space, which means we need to pick a smaller number for the light map resolution. So me, I like to stick to power of 2 numbers, like 2, 4, 8, 16, 32, 64, kind of the numbers that you get for the snap grid here. So I'm going to pick a value of 4, and then let's bake lighting and see what the results look like. Alright, it's kind of noisy because we're in preview mode, but you can see we're getting a lot better shadows off of the different chunks of this mesh. Let me bake again, and I'll set it in production mode, and then we can see what the difference is. And of course, I'll pause the video while it's baking so that you don't have to sit and wait. All right, there we go. Definitely better. So what happens when we increase the density on the surface? We're actually baking essentially a much bigger texture for this wall than for its neighbors. So we get a lot of the better shadow detail. I could even go down to a value of 1, but it's going to take orders of magnitude longer to calculate because it's got to process that much more information. It's also going to take up a lot more memory. The distance is, or the resolution is squared. If I go from a 4 to a 1, that's essentially 4 times as dense, but that's 4 times as dense horizontally and vertically, so it'll actually take 16 times as long to calculate, and it'll take 16 times as much memory. Kind of adds up really fast. So where you can use this to your advantage is tag surfaces only with the resolution they need. If you've got something like this, where you need good sharp shadows, yeah, you can give this wall that much resolution. But this wall over here looks just fine with a light map resolution of 32. And the ceiling, maybe you could even drop it down one more level. Maybe you could get away with 64, so half the resolution. So it's a really powerful tool that you can use to control the memory and to get detail where you need it. Now, one last note with that. If you remember earlier, I mentioned it can be good to tag surfaces with this checkerboard geo that you're never going to see anywhere. Well, if you do that, at this point, you can right-click on the surface, select surfaces, matching texture, and then we can clobber at the light map resolution and turn off all these lighting settings, and then essentially these surfaces get much, much cheaper. So I can set this to a really large number. It'll max out at a certain number, but if you type in something like 10 billion, you're pretty much good to go. And then I'll uncheck these 3 check marks. And now when I bake lighting, I'll save a little bit of time and memory because none of these surfaces effectively are going to receive any lighting. So that's BSP. Light maps also apply to static meshes as well. So let's use this exact same mesh as an example. I'm going to clone it off a little bit closer to the light source and move it off to the side so that we should get a nice hard shadow from these broken bits onto the solid bit of the one that's behind. So let's bake lighting and see what happens. But this time, under the lighting settings, I'm going to use build only selected so that we only bake these 2 meshes. It'll save a little bit of time and we don't need to worry about all the BSP surrounding it. All right. So there we go. You can see that we got shadows baked in that were cast by this object. So if I bring up the properties, let's do the one that's having shadows cast on it. I can go into static mesh actor, static mesh component again, and then we've got a couple settings here. Overridden light map res, override light map. Essentially this is turned off, which means we're using its default light map resolution, which is 64. Now for a static mesh, light map is opposite of what it is for BSP. This literally is the size of the texture that's being used on this mesh. So it's using a 64 by 64 texture. Versus BSP, a 64 would mean 1 pixel every 64 units. So essentially 64 is pretty good resolution. So we're getting relatively sharp shadows. Now you can see how that maps out if you right-click and find in Content Browser, or use the shortcut Control B. So there's our mesh. If we double-click on it, that opens up the static mesh editor. And this icon here in the top left corner says Show UV Overlay. So this gives me the actual UV mapping of the object that's being used to generate light maps. I can zoom the viewport. I can zoom it out so we can see that a little bit better. But essentially, this is the top, this is the bottom, and then these are all the broken chunks. So it's mapping it out pretty nicely. So if you imagine a 64 by 64 texture containing all the lighting for this, it's pretty reasonable resolution. And that's what's set up right here. This is the default. So if we wanted to, I can close that out, and we can override this. I can say yes, and let's type in a value of 256. Now I'll bake lighting on just those objects, and let's see what the results look like. note that it's taking significantly longer to bake. The light maps look maybe a little bit better, but they're kind of blurry anyway just because of the distances between the objects. So it didn't really add much to the quality. It added a lot to the bake time, and it's literally, like I said, 256 is 4 times bigger than 64, but multiply that by 2 dimensions. So this is actually taking 16 times as much memory as when I had the smaller light map on there. So we're better off leaving that at 64.